Today's lesson is lesson 91. It is called The Effect of Scaling on Perimeter, Area, and Volume. We're mainly going to focus today on squares, rectangles, cubes, and rectangular prisms, but these principles also apply to circles. So if the dimensions are changed proportionally by a scale factor, then certain ratios apply when we are comparing the perimeter, the area, and the volume of different shapes. So here we have two squares. This square has a side length of 2 units, and this square has a side length of 4 units. So to figure out the scale factor, we ask ourselves, how do we get from 2 of a side length of our smaller square to 4, which is the side length of our larger square? So the scale factor between these two squares is 2, because 2 times 2 is 4. If I want to figure out the perimeter of this small square, perimeter means distance around the outside. So I do 2 plus 2 plus 2 plus 2, or 2 times 4, which is 8. If I wanted to find the perimeter of the larger square, I would do 4 plus 4 plus 4 plus 4, or 4 times 4, which is 16. All right, the cool thing about scale factor here is that if I took the perimeter of my smaller square and multiplied it by my scale factor, I would get the perimeter of my larger square. If we're thinking about area of a square, to find the small square area, I do base times height, or length times width, which is 4. To find the area of my larger square, I also do length times width, or base times height, and 4 times 4 is 16. If I'm thinking about units for area, I should have written units on my perimeter. Let me go back and do that. All right, units for area is units squared. And so if I look at my scale factor and square it, because my units are squared, 2 squared is 4. If I take 4 and I multiply it by my scale factor squared, which is 4, I get the area of my larger square. If I turn these into cubes, so a 3-dimensional cube with a side length of 2, and I wanted to find the volume. My volume is base times width times height, or 2 times 2 times 2, which would be 8 units cubed. If I did the same thing with my larger square that has a side length of 4, my volume would be 4 times 4 times 4, which is 16 times 4, or 64 units cubed. If I think back to my scale factor, which is 2, and I cube it because I'm talking about volume, 2 cubed is 8, and 8 times 8 is 64. So the cool thing about all of these scale factor dimensions is that these ratios apply to any shapes that are changed proportionally. So if I find my scale factor, I can do a whole lot with that. If I'm talking about the ratio of perimeters, I just multiply by my scale factor. If I'm talking about my ratio of areas, remember the unit for areas are squared, so I take my scale factor and I square it. And if I'm talking about the ratio of volumes, remember the unit for volume is cubed, so I take my scale factor and I cube it to figure it out. So let's say we wanted to find the surface area, this will be example 1, the surface area and volume of a 3-inch cube. All right, so if we think about a cube, how many sides does a cube have? Well, it has 6, right? And each side has a length of 3. So to find the surface area, I need to find the area of one side. So if I found the area of this side here, 3 times 3 is 9. And I have 6 sides in my cube that are all the same. So 9 times 6 is 54. And because it's area, it's going to be inches squared. If I wanted to find the volume of this cube, I do base times width times height. 3 times 3 is 9, and 9 times 3 is 27, and volume is inches cubed. All right, so let's say I wanted to compare the surface area and volume of a 9-inch cube instead. So if I didn't want to do all that math, I could make my life a lot easier. All right, so if I wanted to compare their surface areas, first I need to find the scale factor. So how do I get from 3 to 9? Well, I multiply by 3. So my scale factor between these two cubes is 3. So if I'm now comparing their surface area, remember area's units are squared, I'm going to square my scale factor. So I'm going to take the smaller surface area, which is 54, and multiply it by my scale factor squared, which is 9. So 54 times 9, 9 times 4 is 36, 9 times 5 is 45, plus 3 is 48. So my surface area of a 9-inch cube would be 486 inches squared. The same thing applies when I'm talking about volume. If I want to compare the volume, I take my scale factor. Remember, volume's units are cubed, so I'm going to cube my scale factor. 3 cubed is not 3 times 3. 3 cubed means 3 times 3 times 3, which is 27. So I'm going to take my original volume of 27 and multiply it by my scale factor cubed, which is 27. I have to erase this to fit my work in here. So if I did 27 times 27, 7 times 7 is 49, 14 plus 4 is 18, placeholder, 2 times 7 is 14, 2 times 2 is 4, plus 1 is 5, and so if I add these, my volume of my larger cube would be 729 inches cubed. All right, these ratios always apply as long as the dimensions of the object are changed proportionally. So let's look at one more example. If I wanted to find, let's say I had 2 rectangles. So I have 4 inches here, 2 inches here, and 6 inches here. All right, let's find the scale factor of the smaller rectangle to the larger rectangle. So I have to look at the side lengths that line up. So this top length is 4 inches, but I don't know this length here, so that doesn't help me right now. All right, this is 2 inches, and I know this is 6 inches. How do I get from 2 to 6? Well, my scale factor would be 3. So if I wanted to find the ratio of their perimeters, I could do that. So the smaller rectangle, the perimeter would be 4 plus 2 plus 4 plus 2, because I want to add up all of those sides. So I would get 6 plus 6, which is 12. If I think about the larger rectangle, this would just be inches, right? Because perimeter is just plain old units. I would take the smaller perimeter and multiply it by my scale factor, which would be 12 times 3 would be 36 inches. So let's see if that adds up. If I go 2 times 3 to get 6, 4 times 3 is 12. And so if I found the perimeter that way, I would have 12 plus 6 plus 12 plus 6, which does happen to add up to 36 inches. All right, so what if I wanted to compare the ratio of the areas to find the smaller rectangle? I do 4 times 2, which is 8 inches. To find the larger rectangle, I take my smaller rectangle and I multiply it by my scale factor squared. Why do I square it? Because area is squared, and so 3 squared is 9. So 8 times 9 is 72. Let's see if I got that right. If I did it the old-fashioned way of 12 times 6, I would also get 72, and it should be inches squared. Excuse me. If you need extra practice, please check out the practice set in your textbook on page 613. You can check if your answers are right with the answer key that's also posted in Google Classroom. Please check Alex for your homework for lesson 91.